Instantaneous power. Well, we know power is the voltage times the current. And if we use Ohm's law, we know V equals what? I times R. So we can write that as what? I squared. If you replace V with I times R, it'll be I times I, that's I squared times R. Or if I replace I with V over R, I'll end up with what? V squared over R. We can use either one. So let's take a capacitor, inductor, and see how much power. So for example, if we take a circuit that looks like this.
Where are you in the book, by the way?
We are in chapter 11. This is, we'll call it V, N, as a function of time. I'm just not writing that. Going through a resistor, going through an inductor. Oh, I labeled twice, I guess, plus minus, I already did that. Let's still call this VL. And the question, what is the average power, instantaneous power, delivered, supplied by the load, by the inductor? And if you want to find that, you go, well, what is that voltage? Voltage is VL as a function of time times the current. V for inductor is what? L di dt. If we call this I going in it, di dt times I so the average power, or not the average, instantaneous power, it's L I sub t di sub t dt. And whatever the value happens to be, we plug it in. And again, if it's a capacitor, if you have a capacitor instead of inductor, you go, what is the average power? I'm instantaneous, I keep saying average. I'm going to the average power, that's why. Instantaneous power is a function of time. Through a capacitor is going to be the voltage across the capacitor times the current through the capacitor. So the voltage across the capacitor, and the current's what? 1 over C, the integral, well, I can replace actually I with C dV C dt if I want to. I can do either way. I can replace this V equals 1 over C, the integral of I dt, or I equals C dV C dt. As I said, I can do that, or I can take the voltage crossed, if I'm trying to write them in terms of one variable. If I know one, and if I know the current instead of the voltage, V equals what? 1 over C, the integral of I dt. times I sub c. So I can write it either way. So it's 1 over c, the integral of I times I is I squared.
Can you move the paper up a little bit? That I dt times I.
That's Vc. V equals 1 over c, the integral of I dt, times the current. Yep. That's I here. My handwriting's horrible. So you can do it either way. You can write in terms of voltage, in terms of current. I mean, you can. I did in terms of the voltage here, in terms of the current. And I can do the same thing with this. How's that? Yep. But here's what we found out. That if you have a circuit like this, and let's say your voltage happens to be some Vm cosine Wt. If Vn equals some, like let's say, I don't know, some value with cosine Wt, and you calculate the voltage cross L, you'll find out that the voltage cross the inductor, it has some maximum value, cosine Wt. That doesn't change, but it's going to have a phase shift. And if you take the derivative of that, derivative cosine is what? Negative sine. And that's really nothing more than just changing a phase shift. So the current through that will be, instead of derivative, I can write I sub m cosine Wt plus a different angle, theta. Again, it's L times the derivative. The derivative of this is going to be what? If you do the math. I equals LD, or V equals L di dt, right? Or I can say 1 over L the integral of Vm, I'll push it up in a minute, cosine Wt plus phi. Isn't that the integral? It's the integral of I dt. The integral of v dt, 1 over L, the integral of v dt, I mean. And when you can factor this one out, you have a V maximum over L, some integral of cosine Wt plus phi dt. Who has a derivative cosine? Isn't that the sine? Derivative sine is a cosine. Sine Wt plus phi times W, actually. I mean over W. The derivative, not, we're talking about integration here. Over W, V max over L. This is a constant right here. Some number, we'll call it I sub m. It's going to be a number, Vm over L times W on the bottom. Some constant, sine Wt plus phi. I don't like sine. I'm going to convert sine to a cosine.
Wouldn't it actually be negative?
No, it has a derivative cosine.
Cosine is
It's sine, right? Derivative sine is a cosine. Yeah. And now we need to convert that from sine to cosine. What do we do to convert from sine to a cosine?
phase shift 90 degrees.
Positive or negative?
Negative.
So this becomes I sub max cosine Wt plus phi minus 90. So you have actually a different angle here. I call it theta. So that's why I said if you have a voltage of this, your current is going to be the same thing. The angle will be different. That's all that's going to happen. You have a different angle. I'm just showing you the math behind it. Here I just stated that, and there's the math. Between the voltage and the current through this, there's a shift of 90 degrees. Between this and that, it's a different story. Yeah. So let's see what will happen to the, if I use that equation, if I use these two equations, we know the power, instantaneous power. So I'm going to use these green equations. This is just derivation of that. Power, it's, we said, the voltage times the current. The voltage is what? V max cosine Wt plus phi times I sub max cosine Wt plus theta. I can take V max and I sub max, factor them out. What's left? Cosine Wt plus phi cosine Wt plus theta. Now we have a trig identity. Color trig identities. Let me look at them. What's cosine alpha plus beta? Isn't that cosine alpha cosine beta minus sine of alpha sine of beta, right? I don't know why I put parentheses. I'm not using parentheses there. We also have cosine alpha minus beta to be cosine alpha cosine beta plus sine alpha sine beta. These are trig identities. What will happen if you add these two identities? These two will cancel each other out. You'll have cosine alpha plus beta plus cosine alpha minus beta equals 2 times cosine alpha cosine beta, which means cosine alpha cosine beta is equal to 1/2 Why am I interested in that? Look right here. I have cosine times cosine. I can use this identity. Cosine times cosine, I can use this. This is my alpha. This is my beta. So I can take this, replace it with that. So I'll have Vm I sub m over 2. So this equation right here becomes Vm I sub m over 2, because the 1/2 here, times cosine the sum of them, Wt plus, I'm going to call this, instead of phi and theta, this is theta v and theta I. You add them, cosine the difference between them. When you subtract them, that's theta v minus theta I. And this should be 2w here. I'm sorry, 2. You're adding them. Wt and Wt is 2 of them. That's a plus here, right? I'm using this plus that. So I can break it down to two parts now. Instantaneous power equals V max I sub max over 2 cosine theta V minus theta I. I'm going to break it down to two parts. Plus V max I sub max over 2 cosine 2WT plus theta V plus theta I. Why am I interested in that? I'm not really interested in this equation now. I'm interested in the average power. And the average power is defined, P average. I can write AVG so you know it's average. It is 1 over the period, the integral of the instantaneous power. That's what the average power is. All of this to derive that equation I'm looking for. 1 over full t is a full period here. So it's 1 over t, the integral. Let's put the instantaneous power. Plus, this is from 0 to t, dt, plus 1 over t, the integral over a full period of V max I sub max over 2 cosine, I broke it down to two parts, 2WT plus theta V plus theta I dt. So I broke the average power of this equation into two parts. I'm making the integral of this, the integral of that. Well, this is a constant. This is a constant. So I can take it outside. There's no t in it. So what's the integral of dt? T. So here we go. 1 over t, V max, I sub max, over 2 times t as t goes from 0 to t. Plus, what is the integral of a cosine function over a full period? Think about the definition of integral. The integral means what? The area under the curve. If you integrate a cosine function over a full period, this is t. What is the integral going to be? What is this area when you add it? Calc 2. How about a 0? The positive will cancel the negative. So the answer to this part is really a 0. So now you let t be capital T, what will happen to that t? It cancels out, and there's the equation I'm looking for. The average power is V max I sub max over 2. Oh, I left out cosine here. I left the cosine out, right? There's the cosine in that piece, and I left it out. Cosine theta V minus theta I. So this will be cosine theta V minus theta I. That's the average power. And the equation you'll see in almost every circuit book, it's 1/2 instead of over 2. Some people use 1/2, some people over 2. But 1/2 V max I sub max cosine theta V minus theta I. That's the average power. Now, when you're going to find out the average power by an inductor, it's always going to be 0. Why? Because theta V minus theta I is going to be 90 degrees. For inductor and capacitor, one is plus, one is minus. The phase shift of 90 degrees. That's it. That's all you have. And the average power by the capacitor absorbed is 0. So what is the average power absorbed by capacitor and inductor? Always a 0. Again, the reason this theta V minus theta I will be either plus or minus 90. It depends if it's inductor versus a capacitor. And cosine plus 90 degrees or cosine negative 90 degrees is always a 0. 0 times anything is 0. So all this just to derive this lovely equation in our book. I just wanted to go through the math and derive it. And this is the equation. The average power, it's 1/2 phi max I sub max cosine theta minus phi, or theta V minus theta I, basically. That equation right here. So let's take an example and go through it and see. I'm done deriving, done with the math, with the calculus here. Given that the voltage across here, I don't have the circuit yet, but the voltage is 4 cosine pi t over 6 volt. Find the average power. Find P average and the instantaneous power that results when this voltage is applied across an impedance. So if you take this voltage and put it across an impedance of 2 angle 60. What is the average power and what's the instantaneous power? Now, it might be easier if I switch them to a phasor. The voltage source is what? 4 angle 0? This is 2 angle 60, which means I can calculate the current through that. I is going to equal what? V over Z, 4 angle 0 divided by 2 angle 60, which is what? 2 angle negative 60. So I know the current going through that load as a function of time. The current's going to be what? 2 times cosine pi t over 6 minus 60 degrees. Now, can we get with instantaneous power? It's V times I. We know what V, which is what? 4 cosine pi t over 6 times 2 cosine pi t over 6 minus 60. The instantaneous power is 8 cosine pi t over 60, or 6, not 60, times cosine pi t over 6 minus 60 degrees. I can use my trig substitution, you know, with cosine. Cosine is 1/2 cosine the sum of them plus cosine the difference, but that's fine. I can leave it like this. If I do that, I can write that, when I say use my trig substitution, I'm talking about this green stuff we just derived. Where is it? This one. That cosine, when you have multiplication, it's 1/2 cosine the sum plus cosine the difference. Remember that? Cosine is 1/2 cosine the sum plus cosine the difference. So if I do that trig substitution, this will be 8 times 1/2 cosine the sum. When you add this, 2 pi t over 6, that'll be pi t over 3, because 2 of them cancel the 6, make it a 3, minus 60 plus cosine the sum of, the difference of them, this minus that, which is negative 60. Eight, that's 4. Distribute the 4 through. I think cosine negative 60 is not 1/2. 1/2 times 4, that's a 2. That's instantaneous power. You tell me what time and I'll tell you what the power is. Tell me at what value for t. And I can plug it in, calculate what the power is. The average power it's 1/2 v max I sub max cosine theta v minus theta I. Let's go back to my circuit. What is the maximum voltage across this? Isn't that 4? What's the maximum current? Isn't that 2? Cosine, what's the voltage phase shift here? 0. Minus, what's the voltage phase shift for this? Negative 60? Minus a minus 60, that's plus 60. 4 cosine 60. Cosine 60 is 1/2 times 4. That's a 2. And the units for power is always what? Watts. So the average power is 2 watts. The instantaneous power depends on what time you look at it. That equation, we use it all the time. Average power. I'm going to put a box around it. That's a heavily used one. Asterisk there. 1/2 v max I sub max cosine theta v minus theta I. Now, what you're going to find out if you have a resistor, I mentioned that early, but I'll summarize it here. with the average power, going back to the equation. I'll derive them actually, so you get to see them. Pick a value for a voltage source in phasor. Just give me a value in phasor.
4 angle 20.
Good, 4 angle 20, Joe. There we go. Take a resistor. Pick a value, resistor. Let's say 2 ohms. Make life easy. Right? What's the current? I equals what? 4 angle 20 divided by 2, which is what? 2 angle 20. So the average power, it's 1/2 V max, I sub max. And this is the part I want you to pay attention to, is cosine theta V minus theta I. What's theta V? 20 minus what's theta I? 20. What's 20 minus 20?
0.
What's cosine 0?
1.
So the average power by a resistor, it's always going to be 1/2 V max, I sub max. Always. There's no cosine theta V minus theta I. The phase difference will be 0. Cosine of 0 is 1. Ohm's law, V equals I times R. You can do 1/2 times what? I squared, or 1/2 V max squared over R. You can use any one of them. That's for a resistor. So this is when you have a resistor. Let's look at an inductor, and we'll look at a capacitor and see what the average power. Let's take an inductor. We'll use the same values. This is 4 angle 20. Yep, was it 20? Yep. Instead of 2 ohms, the inductor will be 2J. Which means 2 angle 90. Can we calculate what the current is? 4 angle 20 over what? 2 angle 90. What do we have? 2 angle negative 70 degrees. P average for an inductor, it's 1/2 V max, I sub max, cosine, again, pay attention to this, theta V minus theta I. What's theta V? 20 minus, what's theta I? Negative 70, that makes it plus 70. What's 20 plus 70? 90, right? What's cosine 90 degrees? 0. So the answer is always 0. The average power absorbed by an inductor is always a 0. Why? Because that angle, theta V minus theta I, is plus 90 degrees. Now let's take a capacitor, since we're on a roll here. Capacitor. Same numbers. I won't even change them. 4 angle 20. The capacitor will be negative 2J, which means 2 angle negative 90. The current I will be 4 angle 20 over 2 angle negative 90, which is 2 angle 20 plus 90, 110. P average for a capacitor, it's 1/2 V max, I sub max, cosine, here we go again, theta V. Theta V is what? 20 minus theta I, which is 110. 20 minus 110 is what? Negative 90. And what's cosine negative 90? 0. So in the future, don't waste your time on them. It's always going to be a 0. The average power for a capacitor and inductor is always a 0. Always. So let's take a circuit and see what happens there. Here's an example. We're going to take advantage of this shortcut here. Here's my circuit. =20 0. J2 or 2J, 2 ohms, negative 2J, another voltage source here, =10 When we in phasor, if you remember, we use capital letters. So this is I sub 1, this is I sub 2. Find the average power absorbed by each of the 3 passive elements, by the inductor, the resistor, and the capacitor. And so we'll see if the power supply equals power absorbed there too, by the way. I need to find I sub 1, I sub 2. I'm going to find the average power supplied by the sources, absorbed by the other ones, and see if it adds up to power supplied equals power absorbed, average power. How do we find I sub 1, I sub 2? 2 equations by 2 unknowns. Mesh analysis, right there. Negative 20 angle 0 equals, or plus, not equals, plus (2j) times I sub 1 plus 2 times, what's the current coming down? Is it I1 minus I sub 2? Two plus 2j I sub 1 minus 2 I sub 2 equals 20. 20 angle 0, just nothing more than 20. But if you want to put 20 angle 0, that's fine. It's the same thing as 20. That's the first equation. The second equation, let's take this side. 10 angle 0 plus 2 times I sub 2 minus I sub 1 minus 2j times what? I sub 2 equal to 0. Negative 2 I sub 1 plus 2 minus 2j I sub 2 equals negative 10 angle 0. That's my second equation. I'll go to my calculator. I have two equations by two unknowns. I'll solve that and see what happens. Simultaneous equations. Yep, two of them. Put the coefficient for the first one, 2 comma 2. The second one, -2. Enter. Go to -2. And the other one, 20 angle 0. This one is -2, 2 comma -2, and this one -10 angle 0. Solve. I got I sub 1 to be 11.18. We'll give you the valid angle. I sub 2 equals 7.07. Angle what? -63.4. -45. Now, let's see what is the average power by the resistor. So let's go through one by one. Let's begin with the source. Let's see if it's supplied or absorbed. Here we go. The average power. P average by the 20 angle 0. That's this source. You have a current entering the minus that's being supplied. So it's a negative being supplied. 1/2 V max, which is 20. I sub max, that's I sub 1. Where's I sub 1? 11.18. Cosine theta V, which is 0, minus theta I, and I for I sub 1 is -63.4. And that number is, get out of this, quit. Times cosine 63.4. I get 50.06, -50.06. I'll just say -50. That's 50. Supplied. Negative means supplied. Average power by the 2J. I don't have to do any math. That's a 0. Capacitors and inductors don't absorb or supply anything. 0. The average power, while I'm at it, by -2J, it's also 0. The top. The average power by the 2 ohm. I need to know the current through it. So it's 1/2. I'll use I squared max times R. But I need to know what I. And what is I? I for that is going to equal I sub 1 minus I sub 2. So let's go to our calculator, subtract I sub 1 minus I sub 2. And I came up with 5 angle -90. I use that value here, 1/2 I squared, that's 5 squared, times R, which is 2, that gives me 25 watts. That's positive. It's taken, observed there. Resistor doesn't supply any power, the resistor. Let's see if this one actually absorbs 25 watts. If it does, we're in good shape, because the power supplied has to equal the power absorbed. So let's go to that one. We know the voltage, that's 10 Vmax. We know what the current I sub 2, we'll get to it. So P average, I'll move it up in a second, and that's the 10 angle 0, equals 1/2 Vmax. Vmax is 10. I sub max, what's I sub 1, I sub 2? 7.07. Cosine theta V, which is 0, minus theta I, what's I sub 2? Negative, that becomes 45. $25, which is 25 watts absorbed 2. So notice the power supply equals the power absorbed. There's all the values, one by one. The power supply is 50 watt. The power taken 50 watts. The capacitor and inductor, 0 average power.